Good morning, ladies and gentlemen. We have a question today. How can we measure the speed of sound in the classroom?
Yeah, we tell you what the speed of sound is. We could be lying.
Yeah, and the book says 343 degrees at 20 degrees Celsius. Is this 20 degrees?
I don't know.
I don't know. Okay. First thing I want to talk about is my tuning forks here. A tuning fork vibrates at a known frequency, producing a sound with a specific wavelength. And you can see the frequencies on here.
512
Okay.
hertz.
384
cycles per second.
and 256
56 cycles per second. So,
okay, so you can smack this guy there. I put it on the board, it sounds better. So that's what 512
try another one.
sounds like. Oh. Okay, and then last but not least. Okay, so these are our tuning forks. They produce, they vibrate at a known frequency, producing a sound with a very specific wavelength. Okay, for a tube immersed in water, the length of the resonating air column changes.
Here, I'll bring it over to
as
you.
it pulls up. Okay, so we talked about our closed pipe. One end is closed because of the water, other end is open. And so when I just hit this, it makes that noise, right?
And what determines the frequency of that sound?
The frequency is determined by the length of our pipe, of our resonance structure here, of our resonating air column.
Yeah, but when you have the pipe in water, it's like having your hand right here. As you pull it out, you change the length of the resonating column because the air only goes down to where the water is.
Yeah, and so I can, do I start with it higher here?
Oh, it doesn't matter. Oh, cool.
Right, can you hear that okay?
Yeah. As opposed when you do it with just this, you only, blow on that one. That frequency is determined by the length of the pipe, but this, you can change the length.
It really should be closed on one end.
Yeah.
So you just said this, Boykin, the frequency is determined by the length of the pipe.
Yep.
And, this is just like the poster thing we did the other day, right? When we were banging the poster on the ground.
Exactly
right?
the same.
Okay, so the air column is a closed pipe resonator, yes. Use what you know to find the speed of sound in the classroom today.
Okay, now if you were here and you had a group of 4, you'd be doing it to get figured out what to do together. But what's that basic thing about the speed of sound, the velocity of sound? What's that equation?
The equation. So we know that velocity equals the wavelength times the frequency, yes?
Right, okay, and we can get the frequencies. It's stamped on the tuning fork.
Oh, okay, so we know this. Okay, so this is from the fork.
Yeah.
From the fork. And then what about the wavelength?
Well, I think you should demonstrate what happens when you hold the tuning fork over the column.
Oh, yes. Forgot about that. Okay, so, I guess I'll just start it down here. Oh.
Okay, not there. Go down. Oh. And so she's changing the length, and because you have a fixed frequency, there's only one length try it with another one.
All right, let's do this guy. Oh, right there.
Not up there. Only right there. And now try the other one.
Okay. Ooh, right there.
Notice that lower frequency, you have to pull it out of the water more. So, think for a moment, what do we have to measure?
Interesting. So remember you just said lower frequency, you have to pull it out of the water more. How much fits in here? How much of a wavelength?
Yes, boys and girls, for a closed pipe resonator, how much of a wave is in the pipe? No, we don't have
We
it.
don't have it up there?
Nope.
That's a good
That
question.
was yesterday.
Okay, so how are
Let's
we gonna
just
do
measure.
this?
Let's just measure. We're gonna
do it?
stop right now,
Okay.
and we're gonna measure the length of the pipe pulled up out of the water. So let's get set up, and we'll come right back to you. Go.
And we're back.
Which tuning fork do you want to use?
Let's go ahead. Let's use the highest frequency one first.
Okay, and what is that? Read that.
512
Make note of that, boys
cycles
and
per
girls.
second. Okay, so I'm gonna go ahead and find it. I'm gonna hold it where it's at, and then Boykin's gonna trap it, and I will measure it. And here we go.
Up and down until you get the loudest. Down.
Right there, yeah.
Up and down until you get the loudest. Try that again, because I think I might. Just
Yeah?
hit it, see if it's loud where I've got it.
Oh, right there, yep.
All right.
There we go. Okay, so from the water level, I'm right there. We'll call it 15.5.
15.5 centimeters is 0.155 meters.
Let me get my board. 0.155 meters. We're almost ready. 0.155 meters. Wow,
And
that
that's
doesn't show very well.
512 cycles per second.
Dang, look at that. Look at that quality right there. Okay, let's use this one.
So the question for you boys and girls is we've got 0.155 meters of an air column here. How long is the whole wave? Is the whole wave in here? I don't think so.
How much of a wave is in there?
That's right.
Okay. So should we do this one with them on the board and then?
Why not?
Okay. Oh, I need my marker. All right, so we want to find the velocity, and my data points are right here. So my frequency was 512 cycles per second.
Let's go ahead and use 0.155. See what we get for the speed of sound.
155. 0.155. Okay.
0.155.
5 meters. Okay. Thank you, sir. Okay, so 0.155 times 512, and we get 79.36.
That can't be right.
can't be
79
right.
meters per second?
Oh, you know what we did here?
What?
So we were asking the kids, so this is not a full wavelength. This is a quarter of a length.
That's
wavelength,
right.
Right?
A closed pipe resonator has 1/4 of a wave in there.
Yeah. So if this is a quarter of a wavelength, that means that
How long is the whole wave?
it's gonna be 4 times as much.
Yeah, so
right?
1/4 wavelength equals 0.155.
Oh yeah, I'll
See
write it
what
like
you
that.
have up there, which
Yeah.
equals leave what you had equals 0.155.
And then we can.
How can you solve that for wavelength times 4?
Okay, let's get that number. Can you see it right, Boykin?
Yeah.
155 times 4, and I got 0.62 meters. Okay, so instead of our wavelength being 0.155 meters, it's actually 0.62 meters. So let's go ahead and put that in here. 0.62 meters. Multiply that times 512, and we get 317.
All right, now that's much closer
Yeah.
to the speed of sound that we've been using.
What were 343, right?
Well, yeah, at 20 degrees Celsius. Now the temperature in the room is not 20 degrees, but there's error in here. Where might error creep in?
What
Let's,
did we measure?
well, how did we measure?
No, so yeah, how did we measure? Well, we played it by ear, right? We listened to where we thought it was the loudest,
Yeah.
right? And then we push it over this way. We might have messed up there a little bit.
Yep.
We could have meshed up when I was measuring here.
Yeah, where's the
as
surface?
well.
Where is the surface? Because that surface,
there's a meniscus here, right? Let's do another one
Okay.
and let them do it.
All right, so we'll do one more, and we're gonna let you guys do the math for this one. And let's do the height. Let's do this one, the largest frequency.
All right, so
Lowest
write
frequency.
down the frequency, which is
256. So 256 cycles per second. Bada boom. All right, and here we go.
and move it up and down until you get the loudest.
Right there.
All right, got it.
Okay. Oh, this is pretty hard to hold here. We'll call it 32.3.
32.3 centimeters. And you can see the problems associated with making this measurement.
Okay,
So the pipe out of the water is 0.323 meters. And there's the frequency.
256.
Calculate the speed of sound, boys and girls.
You got it. All right, so then once you've done that, the last thing we're gonna have you guys do today, so finish up that for your homework, and then you're gonna do, oh no, I forgot the last part here. Finish up calculating that for your homework, and then,
We need you to make a little report.
yeah, so it's, describe what, and think about what were the materials that we used in
Yeah.
this mini lab here. Tell me, what did I do? What procedure did I follow? Write down what I did. How did I get there?
Yeah.
Tell me what concepts were governing how we were able to find that velocity.
That's right.
And lastly, tell me about the reliability of the results. Are they not? Where was error? Where
Yep.
do we have possibility for error?
Yep. So
Okay.
do that.
So lab report there. And then you're gonna do this problem, AP Physics problem for your response from 1995.
25 years, 26 years, oh my God, oh my God.
Woo! Okay, and it's on Waves and Sound, number 6. It'll be right below.
You can
Go
do
for it.
this. All right.